Welcome to ScienceCover.com. First, pause the video and complete the Do Now task. Check your answers to the Do Now task. Today, we will look at charges. We will focus on the atom, how to draw charge, how to create a static charge, and the interaction between charges. Let's begin by looking at the atom. The atom is made from three particles: the proton, the neutron, and the electron. Protons and neutrons are found at the center of an atom in the nucleus. The electrons orbit the atom in what we call shells or energy levels. Each particle has a different charge. The proton has a charge of +1, a positive charge. The electron has a charge of -1, a negative charge. And the neutron has a charge of 0, so it doesn't possess a charge. A neutral atom should have the same amount of positive and negative charge, so it should have the same number of protons as it does electrons. The atom in this diagram has 3 protons in blue and 3 electrons orbiting the atom. Therefore, it is neutral as it has the same amount of positive and negative charge. The neutrons are irrelevant as they do not carry a charge. But an atom can gain and lose electrons. If an atom gains electrons, then it gains negative charge. If an atom loses electrons, then it loses negative charge, which will leave it positive. We call these ions. So this diagram shows a negative ion, as it has 3 protons, but has 4 electrons. Therefore, it has more negative charge than positive charge. So overall, the atom has a negative charge and is a negative ion. If the atom loses electrons, then we have a positive ion. So this diagram shows us an atom that has 3 protons, but only 2 electrons. So it has more positive charge than negative charge, and therefore has become a positive ion. Now pause the video and try task 1. Let's check our answers to task 1. First, we must label the atom. The electrons are orbiting the atom, and then at the center we have the nucleus made out of protons in blue and neutrons in red. The proton has a charge of +1, the neutron has a charge of 0, and the electron has a charge of -1. How is a negative ion created? An electron must be gained by the atom, which creates a larger negative charge than a positive charge. How would a positive ion be created? The electrons are lost by the atom, and this creates a smaller negative charge than a positive charge. When two insulating materials are rubbed together, electrons can be rubbed from one material onto the other. This can create an overall charge in the material. So if we imagine a rod and a cloth that are both neutrally charged, this means they have the same amount of positive charge and negative charge. We'll represent this in the diagram by having an equal number of positive symbols and negative symbols on the cloth and the rod. So this polythene rod has an equal amount of positive and negative charge, therefore it is neutral. The cloth has an equal amount of positive and negative charge, so it is neutral. But if we rub the rod and the cloth together. Then electrons are rubbed off the cloth and on to the rod. This leaves the rod with a negative charge. And since the cloth has lost electrons, it has been left positively charged. A perspex rod will behave differently to a polythene rod. Rubbing a perspex rod with the cloth rubs electrons off the rod onto the cloth. This means that the cloth has gained electrons and therefore gained a negative charge. But the perspex rod has lost negative charge, leaving it positive. The buildup of charge on a material can lead to small static shocks or a spark forming. This can be dangerous in the case of aircraft. When an aircraft is flying, air passes over the plane and rubs against the plane's surface. This friction between the air and plane causes electrons to be rubbed from one onto the other surface, creating a buildup of charge. The charge on the plane means that on landing, the plane is more negative than the ground, and if it makes contact, electrons can flow in an electric current from the plane to the ground. This spark can cause a fire. So as a safety measure, a rod is attached between the ground and the plane, so the plane is grounded and the charge is discharged. Now pause the video and attempt task 2. Let's check our answers to task 2. In the first diagram, we have a polythene rod and a cloth. When they are rubbed together, the polythene rod will gain electrons and the cloth will lose electrons. This leaves the charge on the rod negative, but the charge on the cloth positive. A perspex rod rubbed with a cloth will lose electrons, so the cloth will gain electrons and the perspex rod will lose electrons. This means that the charge on the rod becomes positive, but the charge on the cloth becomes negative. When a plane lands on the ground, a cable is used to connect the plane to the ground. Explain why this is necessary. So as the plane flies, the air rubs against its frame. This friction transfers charges to the frame of the plane, resulting in a buildup of charge. This could cause a spark as the plane refuels, resulting in a fire. Using a cable between the plane and the ground discharges the plane and prevents any fire from starting. There are two types of charge, positive and negative. Anything without a charge we call neutral. When two charges of the same type are brought together, they repel each other with an equal amount of force. So these two positive charges are brought together, they will repel each other and push away from each other. The force on each positive charge is equal, so we're representing this by the same size arrow. When these two negative charges are brought together, they repel each other with an equal amount of force, so we're representing that with the same size arrow. However, when two opposite charges are brought together, they attract each other with an equal force. So this is a positive and negative charge, and they will be pulled together or attracted to each other with an equal force on each charge. We can summarize this with the rule like charges repel and opposite charges attract. If we look at the interaction between rods instead of particles, then the same rules should apply. These two rods have the opposite charge. The rod on the left has a negative charge and the rod on the right has an overall positive charge. And since we know that opposite charges attract, we can assume that these two rods will be pulled together. If we bring two rods with the same charge together, then they should repel, as like charges repel. So these two negative charged rods will repel each other with an equal size force, and these two positively charged rods will also repel each other with an equally sized force. Pause the video and attempt task 3. Let's check our answers to task 3. If charge 1 is positive and charge 2 is positive, then they will repel each other. If the charge on rod 1 is positive and the charge on rod 2 is negative, then they should attract each other. And if the charge on rod 1 was negative and we see the second rod repel, then it suggests that the charge on rod 2 must be negative. Part B, the charge on the left should be negative, the charge on the right should be negative. What will happen to the two rods? They will be pushed apart, or they will repel, as they have the same charge. One of the rods is replaced with a perspex rod, which is also rubbed with a cloth. The rods are again suspended from the strings and brought together. What will happen to the rods and why? Well, now the rods will be pulled together. And this is because the perspex rod will gain a positive charge, whereas the original rod has a negative charge. So the rods have opposite charges, and opposite charges attract. Let's look at how we draw charge around an object or particle. If we want to show the electric field lines around a positively charged proton, we draw the field lines coming out of the particle. This is because as a positive charge is brought close to it, the positive charge gets pushed away from the proton. However, if I want to draw a negative charged particle, for instance an electron, I should draw the field line arrows travelling into the particle. This is because if I bring a positive charge close to the electron, it will be pulled towards the electron. So the direction of the arrows represents the direction that a positive charge will be moved if it's brought into the vicinity of the proton or electron. The distance between the field lines represents the strength of the field. So the field lines are closest right next to the particles, which tells us that the strength of the electric field is strongest right next to the particles. As you move away from the center, the field lines get further and further apart, which tells us that the field itself, in terms of its strength, gets weaker as you move away from the particle. Now pause the video and attempt task 4. Let's check our answers to task 4. The field lines for a positive charge should be equally spaced but travelling out away from the positive particle. For a negative charge, we draw the field lines equally spaced but travelling in to the negative particle.